Hello, good morning, students.
Good morning, ma'am.
Yes, good morning. So today we are going to start with kinetic theory of gases and radiations. Okay. So we are going to start with kinetic theory of gases. So first now really question answers and discuss madana. Synopsis and discuss madana. Here you can see the first slide, that is what is this kinetic theory. So the kinetic theory was developed in the 19th century by Maxwell. So Maxwell, Boltzmann ಮತ್ತೆ ಕೆಲವೊಂದು ಸೈಂಟಿಸ್ಟ್ ಇದಕ್ಕೆ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಕೊಡ್ತಾರೆ. ಸೊ ಕೈನೆಟಿಕ್ ಥಿಯರಿ ಬೇಸಿಕಲಿ ಇದು ನಿಮಗೆ ಗ್ಯಾಸಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಮತ್ತೆ ಗ್ಯಾಸಸ್ ಅದು ಏನೇನ್ ಲಾಸ್ ಇದೆ ಅದ್ರ ಬಗ್ಗೆ ನೀವು ಇಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ ಆಯ್ತಾ. ಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಸಾಲಿಡ್ಸ್ ಅಲ್ಲಿ ಪ್ಯೂರ್ಲಿ ಸಾಲಿಡ್ಸ್ ಮತ್ತೆ ಅದ್ರ ನೇಚರ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅದರದ್ದು ಯಾವ್ಯಾವ ರೀತಿ ಇಲಾಸ್ಟಿಸಿಟಿ ಪ್ರಾಪರ್ಟಿ ಇದೆ ಅದನ್ನೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಫ್ಲೂಯಿಡ್ಸ್ ಅಲ್ಲಿ ಮೇನ್ಲಿ ವಿ ಡೀಲ್ ವಿತ್ liquids. Then in case of kinetic theory of gases, here we are dealing with the gases, gas properties, gas laws. ಬೇರೆ ಬೇರೆ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಗ್ಯಾಸ್ ಯಾವ ತರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವಿಲ್ಲಿ ನೋಡ್ತಾ ಇದೀವಿ. ಓಕೆ, ಸೊ ಹಿಯರ್ ದ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅಂತ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ನಾವು ಯಾವುದೇ ಒಂದು ಗ್ಯಾಸ್ ಅನ್ನ ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅಥವಾ ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅದು ನೇಚರ್ ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಾದ್ರೆ we require some comparison. ಹೌದಾ? So when you can say that in a classroom ಎರಡು ಸ್ಟೂಡೆಂಟ್ಸ್ ಇರ್ತಾರೆ. So some will be average students, some will be very brilliant students, below average students. ಯಾವಾಗ ನೀವು ಆತರ ಕ್ಲಾಸಿಫೈ ಮಾಡಬಹುದು? When you have one good example, then you can say that the other student is average or below average ಅಥವಾ brilliant ಅಂತ ನಾವಿಲ್ಲಿ categorize ಮಾಡಬಹುದು. ಹೌದಾ? So like that, to study the nature of the gases, we require some specific reference. So adu specific reference ne idenidu ideal gas. Okay, what is this ideal gas? Ideal gas or a perfect gas is that gas which strictly obeys. Id en madutte antandre it will obey the laws. It will obey the laws like Boyle's law, Charles' law and Gay-Lussac's law. Okay, so in physics we have mainly three laws for the gases, that is Boyle's law, Charles' law and the Gay-Lussac's law. So an ideal gas has following characteristics. So ಇಲ್ಲಿ ಕೆಲವೊಂದು for characteristics ಅನ್ನ ಬರ್ದಿದೀವಿ. That is, molecule of an ideal gas is a point mass with no geometrical dimensions. Right? So whatever the molecules of the ideal gas ಏನಿರುತ್ತೆ, it is a point mass. ಅದೊಂದು point mass ಅಂತ consider ಮಾಡ್ತೀವಿ and it has no dimensions. There is no force of attraction or repulsion among the molecule of the gas. So ಅಲ್ಲಿ ಏನ್ gas molecule ಇರುತ್ತೆ, there is no force of attraction or repulsion. ಯಾಕೆ ಹೇಳಿ, ಏನಾದ್ರೂ force of attraction ಇದ್ರೆ ಒಂದಕ್ಕೊಂದು gas molecules they will come together. If there is a repulsion, the gas molecules will go away from each other. Allenu property ne adu exhibit madalla, right? So ideal gas, these are the two special characteristics they have. So we are going to study about the Boyle's law, Charles' law and the Gay-Lussac's law. So already you know that. What do you mean by Boyle's law here? Boyle's law is nothing but what? Anybody remember what is the Boyle's law expression? So all the laws will give you the relation between pressure, volume and temperature. So Boyle's law dalli en constant irutte heli? What will be constant in case of Boyle's law? Anybody knows? In case of Boyle's law, temperature will be constant. How in case of Boyle's law, the temperature will be constant. Yes. And what about the pressure and volume relation? They are directly proportional or inversely proportional? In case of Boyle's law, the pressure and volume are directly proportional or inversely proportional? Yes, they are inversely proportional. Okay, so that is the Boyle's law here. What about the Charles' law? What is constant in case of Charles' law? Volume will be constant.
Yes, ma'am.
Or pressure will be constant. Yes, volume is constant. And what about the pressure and temperature relation? Directly or inversely?
Inversely proportional.
Inversely or directly it is?
Inversely proportional.
Okay. Yes. Okay. So here we are going to see the kinetic theory and the gas pressure. So here you can see the expression. The pressure of a gas is the result of continuous bombardment of the gas molecule against the walls of the container. So if you consider any container here, a container alli whatever the gas molecules are there, they are moving randomly. Randomly, the gas molecules will be moving here. So they will collide among themselves. Aden madutte gas molecules tamanta collide agutte, and sometimes they will collide with the walls over here. The pressure exerted by the ideal gas is given by 1/3 rho c square. So 1/3 is constant. Rho antandre density of the gas agutte. C bar square is nothing but mean square speed. It is nothing but mean square speed of the gas molecule, right? Then if the gas molecules or the gas container consists of n molecules, so idralli n molecules enadru idde, the expression can also be written as, that is 1/3 nm by v into c bar square. What is this v? V is the volume of the container, right? Then next, so these are the assumptions of the kinetic theory. So navilli kelon sari theory questions anna nodtivi. So here what are the assumptions of the kinetic theory? See here, they are constantly moving, aita. So enadru gas molecules, so they are never at the rest position, they will be moving constantly. Then next, they have negligible volume. So adrade volume irutte, andre compared to the volume of the container, the gas molecules volume will be always negligible, have negligible intermolecular force. So now first idralle nodidvi, the force of attraction or repulsion adralli iralla anta. So whatever the force is there, it is very negligible. It undergo perfectly elastic collision. So ille enagutte, idu perfectly elastic collision agutte. So what is elastic collision? It is nothing but the kinetic energy and momentum both are conserved after the collision or during the collision, you can say. They have the average kinetic energy which is proportional to the absolute temperature. Antandre, as the temperature increase adage, the average kinetic energy also increases. Okay. So here you can see the Boyle's law here. So in case of Boyle's law, volume and pressure are inversely proportional, temperature is constant. So Charles' law, you can see this. So in case of a Charles' law here, the volume and temperature are directly proportional and the pressure is kept constant. And in case of Gay-Lussac's law, so now ಈಗಷ್ಟೇ ಏನು ನೀವು ಹೇಳಿದ್ರಿ ಅದೇನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ Gay-Lussac's law ಆಗುತ್ತೆ. ಅದರ ಪ್ರೆಷರ್ ಮತ್ತೆ ಟೆಂಪರೇಚರ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇದೆ, ವಾಲ್ಯೂಮ್ ಇದು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗುತ್ತೆ. Okay, so this is the three laws which we study here. Yes, then next we have equation of state of an ideal gas. So what is this equation of state? So here it will obey one particular equation that is called as PV is equal to nRT. So then PV is equal to nRT. This is the equation. Which equation? That is ideal gas equation anta heltare. So here this ideal gas equation, it will give you the relation between pressure, volume and temperature. Okay, pressure, volume and temperature ge relation kodutte. The Boyle's law is the ideal gas is one which obeys this equation, or we can also say that the gases which obeys this equation, that is called an ideal gas. And then vice versa relation itu aita. So volume, temperature, R is gas constant. Adradu value estide nodi 8.315 joule per Kelvin per mole. Okay, so remember this one. N is the number of moles of the atoms. Next, Avogadro law. So what is Avogadro's law here? Equal volume of all gases under STP, under standard temperature and pressure, contain the same number of molecules, which is equal to 6.023 into 10 to the power of 23. The 10 to the power 23 data. Next, Gram's law of diffusion of gases. So what is this Gram's law of diffusion? This Gram's law of diffusion is inversely proportional to the root mean, that is the root of the density of the gas. It is inversely proportional to root of the density of the gas. Then next we have Dalton's law of partial pressure. So what is Dalton's law of partial pressure? So the resultant pressure of a non-mixing interacting gases is equal to, so the resultant pressure is given by P1 plus P2 plus and so on up to Pn. Yes. Then the root mean square is given by, that is V1 plus V2 plus Vn upon n. So this is mean speed of the molecule. Idanna now summarize ಮಾಡಿ 8 kBt upon pi n ಅಂತ ಕೂಡ ಬರಿಬಹುದು. Kb is called as Boltzmann constant. Okay, ನಾವು ನೋಡ್ತಾ ಹೋಗೋಣ. ಈ ತರ ಏನಾದರೂ ಕ್ವೆಶ್ಚನ್ಸ್ ಬಂದಿದ್ರೆ ನಾವು ಅಲ್ಲಿ ಇದು ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಬಹುದು. ಸೊ ದಿಸ್ ಇಸ್ ರೂಟ್ ಮೀನ್ ಸ್ಕ್ವೇರ್ ವೆಲಾಸಿಟಿ. ಸೊ ಆಸ್ ದ ಡೆಫಿನೇಷನ್ ಇಲ್ಲಿ ನೋಡಿ, ರೂಟ್ ಮೀನ್ ಸ್ಕ್ವೇರ್ ಸ್ಪೀಡ್, ಹೌದಾ? ಸೊ ರೂಟ್ ಅಂತಂದ್ರೆ ಅಂಡರ್ ರೂಟ್ ಬರುತ್ತೆ, ಮೀನ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಅಂದ್ರೆ ಮೀನ್ ತಗೋಬೇಕು ಸ್ಪೀಡ್ ಆಫ್ ಇಂಡಿವಿಜುವಲ್ ಮಾಲಿಕ್ಯೂಲ್ ಮತ್ತೆ ಅದ್ರದ್ದು ಸ್ಕ್ವೇರ್, ಹೌದಾ? ಸೊ ದಿಸ್ ಇಸ್ ರೂಟ್ ಮೀನ್ ಸ್ಕ್ವೇರ್ ಸ್ಪೀಡ್ is given by Vrms is equal to under root of v1 square plus v2 square plus and so on up to vn square divided by n, and this is also is equal to 3p upon rho, ಹೌದಾ? ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ನಮಗೆ 3 kBT by m ಅಂತ ಕೂಡ ಬರುತ್ತೆ. ಎಸ್, next. So this is kinetic interpretation of temperature ಅಂತಂದ್ರೆ kinetic theory or the kinetic energy and the temperature are directly proportional to each other. So ಇಲ್ಲಿ ನೀವು ಫಾರ್ಮುಲಾ ನೋಡ್ತಾ ಇದ್ದೀರಾ, U is equal to 3/2 RT. This is giving you the relation between kinetic energy and the temperature here. So ಇಲ್ಲಿ ನಾವು ನೋಡಿದಾಗ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಅದು ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇದೆ. ಯಾವ್ದು ಹೇಳಿ? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಮತ್ತೆ temperature, they are directly proportional to each other. Then here we have one concept called as degree of freedom. So what is degree of freedom? Degree of freedom anta andre the number of ways, the number of independent ways anta ಹೇಳ್ತಾರೆ, in which whatever the molecules are there, they are free to move in the possible directions. Adanna ನಾವು degree of freedom anta ಹೇಳ್ತೀವಿ, right? So for example, suppose from your home to college, if there are 4 ways to reach from your home to college, so the degree of freedom will be 4 here. Understanding? ಅಂತಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಗೆ ಎಷ್ಟು ವೇಸ್ ಅಲ್ಲಿ ಅದು freely it can move, that is called as what? The independent coordinate systems, that is called as degree of freedom here. So here we have the monoatomic, diatomic and the polyatomic molecules. So the degree of freedom is given by, ಇಲ್ಲಿ formula ಇದೆ ನೋಡಿ, it is 3n minus k. So n is number of molecules. Okay. If it is monoatomic, it will be substituted 1. If it is diatomic, it is substituted as 2. It is polyatomic. Polyatomic ಅಂತಂದ್ರೆ more than 2. So ಅಲ್ಲಿ 3 ಬರ್ಬೋದು, 4 ಬರ್ಬೋದು, 5 ಬರ್ಬೋದು. K is what? K is the number of constraints. So number of constraints ಅಂತ ಅಂದ್ರೆ that is the restrictions associated with the structure. Right? Means, for example, as I told you, if you are going from your home to college, so 4 independent ways are there. ಆ 4 independent ways ಅಲ್ಲಿ, for example, ಯಾವ್ದಾದ್ರು one way ಅಲ್ಲಿ constructions ಏನಾದ್ರು ನಡೀತಿತ್ತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಅದೇನಾಗುತ್ತೆ? It is a constraint for you. It is a hurdle for you, right? So that is 3n minus k. That k will be that whatever the constraint, that hurdle, we can consider it as constraint here. That is degree of freedom. Yes. Then we have law of equipartition of energy. So what is this law of equipartition of energy? Now ಈಗಷ್ಟೇ degree of freedom ಅಲ್ಲಿ ನೋಡಿದ್ವಿ, the molecules are moving freely in independent all the possible directions, ಹೌದಾ? So whatever the energy it carries, that energy is equal to 1/2 kb into t, ಹೌದಾ? ಅಂದ್ರೆ ಮಾಲಿಕ್ಯೂಲ್ ಇರುತ್ತೆ, ಬೇರೆ ಬೇರೆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೋಗ್ಬೇಕಾದ್ರೆ ಅದು ಎಷ್ಟು ಎನರ್ಜಿ ಕ್ಯಾರಿ ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ half kb t energy per molecule it will carry. So half kb Boltzmann constant, t is the temperature. So what is mean free path? So mean free path of a molecule, it is the average distance traveled by the molecule between two successive collisions. So between two successive collisions, it is called as mean free path of the molecule. That is given by lambda 1, lambda 2, lambda 3 up to n particles, it is lambda n. So here you can see the expression, ಆಯ್ತಾ? So the mean free path is given by, so ಇದನ್ನ summarize ಮಾಡಿ simplify ಮಾಡಿ ನಮಗೊಂದು final expression ಸಿಗುತ್ತೆ, and that is given by 1 divided by under root of 2 pi d square into n. Or you can also take it as in terms of Boltzmann constant, it is given by kT divided by under root of 2 pi d square into p, right? So you will note terms ಏನು explain ಮಾಡುತ್ತೆ ಅಂತ, molecular diameter, number of molecules per unit volume, absolute temperature and pressure. Yes, next. So next one. Smaller the number of molecules per unit volume, larger is the mean free path. Then smaller the diameter, larger is the mean free path. Smaller the density, larger the mean free path. So for vacuum, the density will be 0. Therefore, the mean free path value tends to infinity. Smaller the pressure of a gas, larger is the mean free path. Then the higher the temperature, larger the mean free path. So based on this expression, you can give these 5 conclusions here. right? So here one table ide nodi, ee table anna neevu solpa remember madbekagutte. That is for monoatomic Cp Cv then gamma value. So the gamma value is always the ratio of Cp by Cv, hauda? So monoatomic iddaga the gamma value or the gamma ratio is 1.67, for diatomic it is 1.4, for triatomic it is 1.33. Then here also some constant values are given for the particular atom or molecule here. So no need to read by heart this one. This is only for your understanding purpose. So you can see that monoatomic helium, neon, argon, then O2, H2, N2, Cp, Cv and gamma, all the values are given. So below table is giving you the specific heat capacities of some materials. Yes. So to solve the questions, we require these all data. Now we are going to discuss about the question answers. Yes. Okay, hope so you are able to see the screen. Let us start with the question answers. So here is our first question. Okay, the first question is, air is pumped into an automobile tube up to a pressure of 200 kilopascal. They are giving you the pressure value as 200 kilopascal, which is in the morning. In the morning, when the air temperature is 22 degree Celsius. When the air temperature is 22 degree Celsius. Okay, then during the day, the temperature rises to 42 degrees Celsius. So in the morning, the temperature is 22 degrees Celsius, then it is increasing to 42 degrees Celsius. So when it is 22 degrees Celsius, our pressure estimate 200 kilopascal is there. Okay, the tube is expanding by 2%. The pressure of the air when the temperature is 42 degrees Celsius. So artha aita question artha aita 22 degrees Celsius iddaga the pressure is 200 kilopascal. 42 degrees Celsius iddaga what is the pressure? So one hint ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, the tube is expanding. ಯಾವಾಗ temperature ಹೆಚ್ಚಾಗುತ್ತೆ the tube is expanding by 2% here. So how to solve this one? So few students are saying, Soundarya, Harshita, they are saying it is option B 209. Yes, it is 209. But let us solve this question. Okay. Yes, Shweta, Lakshmi. So I feel many of you know the answer, but once we will solve this. So we will solve this question here. Okay, so here you can take down the pressure P1 as 200 kilopascal, right? Then the temperature, I'll take it as T1, which is 22 degrees Celsius. I'll consider it in terms of, that is Kelvin, and it becomes 295 Kelvin. Then T2 is equal to 42 plus 273, it is 315 Kelvin. Okay, so V1, if I imagine it as V, under the initial volume 22 degrees Celsius, the volume I'll take it as V. When the temperature is increases to 42 degrees Celsius, it is expanding by 2%. Andre V2 is equal to V1 plus 2 by 100. Yakandre 2% anta ide of V1. So if you simplify this, you will get it as 1.02. Even then now V anta tagondiddivi. So I'll take it as 1.02 V, that is your V2 value. So now you have P1, T1, T2, V1, V2, everything. We just require P2 value. So what you do, you just take P1, V1 by T1 is equal to P2, V2 by T2. So we'll nodi. So P1 is given as 200. Then next we have V1 value as V, T1 value as 295, T2 value we need to calculate. V2 is 1.02 into V, T2 is given, that is 305. So ಇಲ್ಲಿ P2 ಅನ್ನ calculate ಮಾಡಿದ್ರೆ ನಮಗೆ 209 kilo Pascal ಅಂತ ಬರುತ್ತೆ. That is option B is the right option. Okay. Yes, many are getting the answer. Very good. So let us go for the next question. Second question is, an ideal gas undergoes a process according to the law P is equal to AV. A ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ಅಂದ್ರೆ pressure is directly proportional to volume ಅಂತ ಆಯ್ತು. Initial temperature of the gas is 300 Kelvin. The change in temperature of the gas when its volume doubles is. So ಇಲ್ಲಿ pressure is directly proportional to volume ಅಂತ ಇದೆ. Initial temperature 300 Kelvin ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. The change in temperature of the gas when its volume doubles. So volume double ಆದಾಗ the change in temperature they are asking. So how to do this one? Let us see. So again, this is given by PV is equal to nRT. So here we have PV by nR is equal to temperature. Temperature ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, 300 Kelvin ಅಂತ ಇದೆ. And what the data they have given, that is P is equal to AV ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So can I write it like this? That is P1 is equal to AV1 and P2 is equal to AV2. Now I'll take the ratio of these two. So ಇದೆ ಎರಡು equation ಅಂತೂ ratio ತಗೊಳ್ತೀನಿ. ಏನಾಗುತ್ತೆ ನೋಡಿ, that is P1 by P2 is equal to AA cancel ಆಗುತ್ತೆ ಯಾಕಂದ್ರೆ ಅದು ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. So it is V1 upon V2. So which is equal to, so V1 I'll take it as V, and what they are telling, your V2 is doubling andre 2V anta ಆಗ್ತಾ ಇದೆ, right? Okay. Therefore your P1 V it is option B. Okay. Yes, correct. Okay, all are getting the answer. Very good. Right. So here what we will do, we will just substitute. Your P1 is equal to 2P1 P2 anta aitu. Hauda? So now you can substitute in this equation. That is PV is equal to nRT. Idralli substitute ಮಾಡ್ತಾ ಹೋದ್ರೆ ನಿಮಗೆ temperature ಸಿಗುತ್ತೆ. Okay, the temperature will be. So if you simplify this further, P1 is equal to 2P2 ಅಂತ ಬಂತು ನಮಗೆ. ನಾವೀಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. That is the final temperature TF is equal to PF VF divided by, that is NR. ಹೌದಾ? So this is equal to, so PF final pressure ಎಷ್ಟು ಅಂತ ಬಂತು, that is 2P1 into final volume ಎಷ್ಟು ಅಂತ ಇದೆ, ಡಬಲ್ ಆಗುತ್ತೆ. ಹೌದಾ? So it is 2V1 divided by, it is N into R. So this is nothing but N P1 V1 divided by NR. So what is P1 V1 divided by NR according to this? This is nothing but 300. So 4 into 300. It is 4 into 300. It is option D. What you people are telling? It is option B. It is option D. D baratte, not B. All are telling B only. Lohit is giving D. It is D. It is not B. Yes. I hope the solution is clear to you. If anybody is having any query, you can ask. So if you want, I'll repeat the solution. See, according to ideal gas equation, it is PV is equal to nRT. So idenagate equation PV divided by NR is equal to T. Avaru temperature kottidare ಎಷ್ಟು ಅಂತ 300 Kelvin ಅಂತ. ಹೌದಾ? So ಕೊಟ್ಟಿರುವಂತ equation ಏನು, P is equal to AV ಅಂತ ಅವರು ಹೇಳಿದ್ದಾರೆ ಇಲ್ಲಿ, right? So now ಇಲ್ಲಿ ಏನಂತ ಬರಿಬಹುದು, for initial we can write it as P1 is equal to AV1. For final we can write P2 is equal to AV2. So according to this, if I take the ratio of these two, we will get it as P1 by P2 is equal to V1 by V2. ಇಲ್ಲಿ ಏನ್ ಹೇಳಿದ್ದಾರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ, the volume doubles. So change in temperature ಕೇಳಿದ್ದಾರೆ. ಹೌದಾ? So V by 2V ಅಂದ್ರೆ ಏನಾಯ್ತು, VV cancel ಆಯ್ತು. Therefore it is P1 is equal to 2P2, right? So therefore, according to the equation here, you can substitute the final temperature. You can simplify it as 4 into 300. It is 4 into 300. Yes. Option D, that is 1200. If it is clear, we will go for the next question. So our next question is, okay, so two monoatomic ideal gases, A and B, occupying the same volume V, are at the same temperature. So ಇಲ್ಲಿ ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ, same volume ಮತ್ತೆ same temperature ಅಂತ ಇದೆ, and the pressure is also same. ಆಯ್ತಾ? If they are mixed, so if they are mixed here, ಅಂದ್ರೆ A ಮತ್ತೆ B, these are two monoatomic ideal gases. ಅದನ್ನ ನೀವು mix ಮಾಡಿದ್ರೆ, the resultant mixture has a volume V and temperature T. The pressure of the mixture is, so pressure ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. It is 2P. Yes.
Option D.
Okay, correct.
Option D, ma'am.
Okay. So I hope everybody know this answer. So I'll proceed to the next question. It is 2P. So all are answering yes. It is option D. Now previous case ಅಲ್ಲಿ ಕೂಡ ಅದನ್ನ ಸ್ವಲ್ಪ ತೋರಿಸಿದ್ವಿ ಆಯ್ತಾ. Now a box has two chambers separated by a membrane. One half of volume contains an ideal gas at temperature T. The other half of the volume is evacuated. So you have a box which are thermally insulated. Thermally insulated anta andre the box, first one and the second one, whatever the chamber is there is no exchange of the heat is taking place. One half of the volume contains the ideal gas of temperature T and the other half of the volume is evacuated. If the membrane breaks down, the gas temperature will be. So adenu membrane adu separate ಮಾಡ್ತಾ ಇದೆ, ಅದೇನಾದ್ರೂ break down ಆದ್ರೆ the gas temperature. So the students are seeing it as C. Let us see. It is actually C. So let us prove this one. The temperature remains the same. Okay. So if you require, we can do proof also. See, when they are saying it as it is thermally insulated, it is the adiabatic process. How the adiabatic process agutte? Adiabatic process alli enagutte? There is no exchange of the heat takes place. Alli no exchange of the heat agalla. So when there is no exchange of the heat, what we can write? We can write it as delta Q is equal to. So according to that, we can write delta Q is equal to 0. Then similarly, delta W is also 0. How then? Why? Because here whatever the walls are there, they are rigid. Their walls are rigid here. Therefore, the work done is also 0. The change in energy is also 0. Therefore, the change in internal energy, that will be also 0. That will be also 0. So when there is no change in energy, whatever the temperature is there, it remains constant, and that is T. Option C is correct one. So you can explain this with the help of the first law of thermodynamics also. Next question. According to the kinetic theory of gases, the pressure of an ideal gas and its energy density are related by. So idanna ನಾವು theory questions ನೋಡಬೇಕಾದ್ರೆ synopsis alla ನೋಡಿದ್ವಿ, ಅದರಲ್ಲಿ ಇತ್ತು which expression A B C D. They are denoting energy density by U. Now ನೋಡಿದ್ರಲ್ಲಿ ಅದು E ಅಂತ ಇತ್ತು ಆಯ್ತಾ. It is, so all are saying it as C. Yes, it is C. Okay. C, it is 2/3, not 3/4.
ಬಿಟ್ಟು ಅನೇಕ ಸದೇಕ ಚಿತ್ರಿತ
2/3, not 3/4.
ಯುವಕರ ಬಳಿಗೆ ಗ್ರಾಮದ ಜನರೆಲ್ಲ ಹೋಗಿ ಅವನನ್ನು ಕುರಿತು ಬಾಲಕನೇ, ನಿನ್ನ ತಂದೆಯ ತಾಯಿಗಳು ಯಾರು, ನಿನ್ನ ಹುಟ್ಟಿ ಯಾವುದು ಎಂದು
students, please mute yourself. Okay, so it is option D. Let us go for the next question. So this is direct question. At room temperature, the RMS speed of the molecule of a certain diatomic gas is found to be 1930. That is 1930 meter per second. The gas is. So if you know the theory in detail, you can directly write this. Otherwise, we can prove this also. At room temperature, the RMS speed is of a diatomic gas is 1930 meter per second. Diatomic anta ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು ಇಲ್ಲಿ. And in the example also they have given it as like H2, F2, C2 and Cl2. So let us prove this one. ಯಾವ್ದು ಬರುತ್ತೆ ಅಂತ. Yes. So Soumya, Lohit, Harshita, it is H2. So let us prove. Option A is the right answer. So prove kuda madana navilli. So here that is VRMS is equal to under root of 3RT divided by M. Our VRMS value kottidare, that is 1930. VRMS value is given as 1930. So this is equal to under root of 3RT divided by M. So what I'll do, I'll square this equation on both the side. If I square this equation on both the side, namge square root cancel agutte hauda. So I require M. Namge M bekagutte. Adu yav molecule anta kandu hidibekadre. So that is M is equal to under root, sorry, cancel aitala. Idu 3RT divided by 1930 whole square. 1930 whole square. You can substitute all the values, right? So if you substitute all the values here, at room temperature they are telling, so you can substitute the standard room temperature and the answer you are getting it as 2 into 10 raised to minus 3 kg, or you can take it as 2 grams also. So when you are getting it as 2 gram, it means that it is a hydrogen atom. It is a hydrogen atom. Okay. Yes. So many people know the answer. Very good. So let us go for the next question. The velocity of sound is V at 273 Kelvin. The temperature at which it is 2V is. So the velocity is given as 273 Kelvin. The temperature at which it is 2V is. So we need to calculate the temperature. So some students are telling it as B baratta, A baratta. Let us see. What is B? It is B, that is 4 into 273 Kelvin. So we can show this one, that is here. We know that V is directly proportional to temperature. That is velocity of sound is directly proportional to temperature ante namge gottide illi. So therefore we can take it as V1 by V2 is equal to, it is under root of T1 divided by T2. Yes. So therefore here we can substitute the values. That is nothing but V2 is equal to under root of T2 divided by T1 into V1. Yes. So therefore it is 2V is equal to, it is 2V is equal to T2 divided by 273 into V. V will get cancelled on both the side. So squaring on both the side, therefore we will get T2 is equal to 2 square is 4 into 273. That is nothing but option B is the right option. Yes. So everybody knows this one. Very good. So instead of proving also, here we can understand this one directly. Let us go for the next question. The RMS speed of oxygen molecule of a gas at room temperature 300 Kelvin is. So they are asking you the RMS speed. So this one you can calculate directly. You know the formula. You can do this one. 483. Yes, correct. So here it is 483. How we do this one? That is nothing but. So here we can take it as VRMS is equal to. Yes, it is correct. It is 483. It is nothing but 3 under root of 3RT divided by M naught. So which is equal to 3 into 8.31 into temperature is 300 divided by M naught. M naught value is 32 for oxygen. So if you simplify this, we will get it as 483. So here we need to take it as 0.032 in terms of SI. units. It is 483. Yes, very good. Let us go for the next question. Okay, the next question is the absolute temperature of a gas is increased 3 times the root mean square velocity of the molecules will be. So here the absolute temperature is increased 3 times. What happens to the root mean square? What happens? They are directly proportional. Option A or B? It is
B, ma'am.
3 times. It is 3 times. Okay. As they are directly proportional, it is 3 times. Option A is right. Then the next question is, if the pressure and the volume of a certain quantity of ideal gas is half, then its temperature. So pressure and volume is reducing to half value. What happens to its temperature? So Raju, Soumya is telling it is doubling. So some are telling it as B. Yes, it is B only. So we can prove this one, that is, see what they are saying, the pressure, we know that PV is equal to RT equation, we know how the pressure ಮತ್ತೆ volume ಎಷ್ಟಾಗಿ reduce ಆಗ್ತಾ ಇದೆ, it is reducing by half. So this is nothing but RT, right? So R is constant, adanna bitbidi. So here what happens, it is, so whatever your temperature is there, it is reducing by 1/4. That is, it becomes 1/4. Option B is the right one. Yes, Likit, Lakshmi, Harshita, it is option B. Okay, let us go for the next question. At constant volume, if temperature is increased, then, so this is based on the theory, that is assumption of the kinetic theory. At constant volume, if temperature is increased, then collision on the walls will be less, number of collisions per unit time will increase, collision will be in straight line, collision will not change. It is A antu baralla. How the temperature ಹೆಚ್ಚಾದಾಗ collision will be less. This is not true. Collision will be in a straight line. It is never possible. Collisions will be always in a random direction. Collision will not change. Idanna kuda navu helik baralla. So it is only option B. It's very good, everyone. Soumya, Shweta, yes, it is option B. There is number of collisions per unit time will increase. Option B is the correct option. Then the next question is, root mean square velocity of a particle is V at pressure P. The root mean square velocity of a particle is V at pressure P. If the temperature is increased by 2 times, what happens to your, okay, you are saying the volume velocity, RMS velocity becomes 3V. So everybody is giving option B. Yes. So here actually what they are asking, see, the root mean square of the particle is V at pressure P. If pressure is increased, so nimdu root mean square expression alli pressure term barutta. Pressure, is it having any effect on the root mean square velocity? Then option D it is. Okay, so here the pressure is not affecting the root mean square velocity. Pressure has no effect on the RMS velocity. Therefore, whatever the volume is there, the velocity is there, it remains same, that is V itself. Option D is the correct option. So the explanation is what? The pressure has no effect. Therefore, the volume remains same even though the pressure is increased by 2 times on the RMS speed. There is no effect on the velocity. Next question. A vessel contains a mixture of 1 mole of oxygen and 2 moles of nitrogen at 300 Kelvin. So illenide ಎರಡು ಗ್ಯಾಸ್ ಇದೆ, ಒಂದು ಆಕ್ಸಿಜನ್ ಇದೆ ಮತ್ತೊಂದು ನೈಟ್ರೋಜನ್ ಇದೆ. Oxygen is 1 mole and nitrogen is 2 moles at 300 Kelvin, the ratio of the rotational energy per O2 molecule so that per N2 molecule is. So ratio find out ಮಾಡಬೇಕಾಗಿದೆ ನಾವಿಲ್ಲಿ. Let us see how we are going to do this. Okay, so as see here, whatever O2 and N2 is there, they are which atomic, that is which atoms, they are diatomic. So the diatomic has 2 degrees of freedom associated with the motion. So according to the law of equipartition energy, it carries energy of half kT. It carries energy of half kT. Since 2 gases are at the same temperature, therefore, option, which one? That is option C, that is it is in the ratio of 1:1. ಯಾಕೆ ಹೇಳಿ? Because both are diatomic. ಎರಡು ಕೂಡ diatomic ಇದೆ. According to the equipartition energy, both should carry the energy in both in all the direction, that is half kT. ಹೌದಾ? ಸೊ ಇದೇನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಎರಡರದ್ದು ಎನರ್ಜಿ ಸೇಮ್ ಇರೋದ್ರಿಂದ they are in the ratio of 1:1. So mathematically not required to prove it. We can just understand as both are diatomic. According to equipartition energy, they are carrying the same energy in all the direction. Therefore, they are in the ratio of 1:1. That is option C. Then our next question. The root mean square speed of oxygen at a certain absolute temperature is V. So that is root mean square value is given. If temperature is doubled and the oxygen gas dissociated into atomic oxygen, the RMS speed would be. So how to calculate this one? So when the oxygen is, temperature is doubled, the oxygen gets dissociated into oxygen atom. So what is the RMS speed? Let us calculate this one. That is given by, here VRMS is equal to, already you know that VRMS is equal to under root of 3RT divided by, it is 3RT divided by M. So here the temperature is doubled and then temperature T iddadu 2T anta change ಆಗ್ತಾ ಇದೆ, right? So when the temperature is doubling, what happens to your M? The M is becoming M divided by 2. So let us change this equation. Therefore, the now new equation is becoming VRMS is equal to under root of 3R, T is becoming 2T divided by, that is M by 2. How that? So now how we can simplify? See here, 2 will go to the numerator, 4T agatte, 4 anna horage tegidre 2 agatte. So 2 under root of 3RT divided by M. So what is 3RT divided by M? 3RT divided by M is nothing but your initial VRMS. So therefore your new VRMS is twice of the initial RMS. That is option B. ಇದು root 2 ಅಂತ ಇದೆ. root 2 ಎಲ್ಲಿ ಬರುತ್ತೆ? 2, 4, if you take it outside, it will be 2. So it is option C. It is option C. I hope the
ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ.
ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ, that is VRMS is equal to under root of 3RT divided by M. This is what your given data. The root mean square speed of the oxygen at a certain absolute temperature is V. If the temperature is doubled, ಅಂತಂದ್ರೆ ಕೊಟ್ಟಿರೋ equation ಅಲ್ಲಿ ನಾವು temperature ಅನ್ನು double ಮಾಡಬೇಕು, and the oxygen mass gets dissociated into oxygen atom, ಅಂದ್ರೆ mass M ಇದ್ದದ್ದು M by 2 ಅಂತ ಆಗುತ್ತೆ. ಹೌದಾ? The new RMS velocity is given by under root of 3R. Temperature is becoming twice, therefore 2T. As it is getting dissociated, M is becoming M by 2. So 2, if it goes to the numerator, it becomes 4T. So this is V dash is equal to under root of 3R. So that is 4T upon M. So if I take this 4 out of the root, then it becomes 2 under root of 3RT divided by M. So this is nothing but 2 initial VRMS ಅನ್ನ ನಾವಿಲ್ಲಿ ತಗೊಂಡಿದ್ದೀವಿ. ಹೌದಾ? ಇದೇನು ಇಲ್ಲಿ ರೂಟ್ ಅಲ್ಲಿ ಇದೆ, ಇಲ್ಲಿ ನೋಡಿ equation 1. That is same. Yes. So it is, now is it clear? Yes, okay. Okay, so let us go for the next question. Okay, see the question. The RMS speed of the molecule of a gas in a vessel is 400. Its speed is 400 meter per second. If half of the gas leaks out, so yavaga full gas irutte avaga velocity or the speed is 400. Gas leak adaga at constant temperature, what happens to your RMS velocity? So let us see. It is 800, 400 root 3, 400 or 400 root 2. So the given is what? That is VRMS is equal to 400 meter per second. So initial, whatever the volume is there, it is leaking out. Therefore, initial volume is, if I take it as N naught, and the final volume when it leaks out, I'll take it as half anta ಹೇಳ್ತಿದ್ದಾರೆ. Therefore, idanna ನಾವು N naught upon 2 ಅಂತ consider ಮಾಡಬಹುದು, right? So therefore, VRMS is equal to under root of 3RT divided by M. So here temperature and M, these are constant, right? So when these are constant, R and T is also constant. So what happens to your VRMS? The VRMS remains same, right? So in the all terms of constant ide, even though if it is leaking out, there is no change in the RMS speed. So it remains the same, that is 400. Yes, yes, very good. So everybody is giving the answer, that is 400 meter per second. Why? We have explained that because it has no effect with the whatever the mass is getting leaking out. Then the next question. Okay, a flask contains hydrogen and helium in the ratio 2:1 by mass. So you have a flask alone hydrogen and helium. They are in the ratio of 2:1. The temperature of the mixture is 27 degrees Celsius. The ratio of RMS speed of the molecules of the two gas is. So here the flask, whatever the ratio of the mass is there, it is 2:1. Temperature is 27 degrees Celsius. The ratio of the speed they are asking here. So you can calculate by yourself. VRMS melene idu kuda. You can try it. Try and tell me the answer. It is 1:1.
Option C, ma'am.
Option C. Okay. All are getting option C. So let us see how we are getting option C or option B or option D. So see here, that is the ratio of speed they are asking. So here what I'll do, I'll consider the average kinetic energy. So average kinetic energy is half mv square. So for hydrogen atom, I can write it as mh vh whole square. So this we can take it in terms of the Boltzmann constant. It is 3/2 kT. This is for hydrogen atom, right? Then similarly for helium atom also we can write the expression, that is nothing but 1/2 mhe into vhe square is equal to 3/2 into kT. So if I take the ratio here, that ratio 1/2 will get cancelled. So we are left with what? Only VH upon VHE whole square. So which is equal to, that is MHE upon MH. See 3/2 kT, half everything will get cancelled. We are left with only MV term. So here VH upon VHE whole square is equal to MHE upon MH. ಯಾಕಂದ್ರೆ ಅದು inversely proportional ಇದೆ ಹೌದಾ? Option C. All are getting option C only. So see here what they are saying, they are in the ratio of, that is hydrogen is 2 and helium is, sorry, hydrogen is 2 and helium is 1. Howda? Yes. You are getting it as what? 1 by 2. But here square is there. So what you will get? 1:1 antu baralla. How you are getting it as 1:1? It will not come 1:1. It is A or B. Remaining students?
Option A, ma'am.
Yes, it is A. It is A. Howda gotaita? So that is, we are considering that is half mv square is equal to 3 by 2 kT. So if I take the ratio here, the hydrogen is in the ratio of, that is 2:1. So hydrogen adu 1 anta 2 anta agutte, helium adu 1 anta agutte. So as here VH by V whole square is there, therefore it becomes under root of 1 by 2, that is nothing but 1 upon root 2. Yes. So that is option A. Then the next question. Okay, then the next question is, a tank contains 30 kg of O2. A tank contains 30 kg of O2 gas at a gauge pressure. Gauge pressure antandre difference in the pressure, right? Of 8.7 atmosphere. If the oxygen is replaced by helium at the same temperature, then the mass of the helium required to produce a gauge pressure of 7 atmosphere is. So gauge pressure, difference in the pressure is given. They are asking you the mass of the helium, how much it is producing. So let us solve this. That is given by, so first mass is given as M1 is equal to, it is 30 kg they are giving you. Then the pressure is, it is 8.70 atmosphere. Then I'll take V1 and V2 are same, that is V. For helium atom, so for helium atom the pressure is given as how much? That is 7 atmosphere, right? So now we can use the equation P1 V1 is equal to nRT. Aita? So namge n value gottilla. So what I'll do here, I'll take it as M1 upon mRT. So this is nothing but V is equal to, or V1 andre now V anta heltidivi, therefore V is equal to, it is M1. M1 is how much? It is 30. And next, divided by, for oxygen, it is mass is 32, M1 is given as 30. Then next, R is 8.3. If you want, we will keep it as it is. Into T also I'll keep as it is. So P1 value kottidare avaru, that is 8.7 anta. This is my equation 1. I'll repeat. So M1 is 30 kg, P1 is 8.7, V1 V2 is equal to V, P2 is given as 7. Okay, I'll check that one, previous one. Okay, so P1 V1 is equal to nRT, therefore it is M1 by M is equal to RT. M1 is 30 and M is 32 for oxygen. This is R into T. I hope this is clear. This is for oxygen atom. Similarly, you write it for helium atom. Then you take the ratio, you will get the answer. So next I am going to take it as, that is P2 is 7 into V2 is V, which is equal to M, which we need to calculate, and for helium it is 4 into RT. This is my equation 2. So what you do it as 2 divided by 1. Do it as 2 by 1. 2 by 1 ಮಾಡಿದಾಗ ನಿಮಗೆ m ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ ನೋಡಿ. It is Lohit, I'll check that. Okay, I'll check that once again. See here what you are getting the answer. Do it as 2 by 1. V cancel aitu, so you have 7 by 8.7. Then you have RT will get cancelled. Calculate m. It is option yes. This is equation 1C. 8.7 into V is equal to 30 by 32 into RT. Equation 2 is 7V is equal to m by 4 into RT for oxygen and helium. So take the ratio and calculate the mass of the helium. Getting or no, students? So here it will be how much? 8.7 into V. Sorry, 1 by 2 you do. 1 by 2 you, not 2 by 1. 1 by 2. So 8.7 into V divided by 7V, which is equal to, that is 30 by 32. RT cancel agate, so leave it. This is 4 divided by m. So then V will get cancelled. Here 30 into 4 divided by 32. You will get it as 3.75, and here it is 1.24. So 3 divided by m here. Therefore m is equal to. Now it is option C, 3.09. Anybody is getting the answer? Option C, 3.75 divided by 1.24. Yes? Okay. I hope the solution is clear to you. Let us go for the next question. Okay, a storage tank at STP contains 18.5 kg of nitrogen. The volume of the tank is, use PV is equal to nRT. In that you need to calculate V. So how to do this? That is, see here, m is given as 18.5 kg. M is given as 18.5 kg. At STP, andre temperature estaಗುತ್ತೆ 273 ಅಂತ ಆಗುತ್ತೆ. Pressure estaಗುತ್ತೆ 10 to the power of 5 ಅಂತ ಆಗುತ್ತೆ. ಹೌದಾ? For nitrogen, the m value is 28 grams per mole. 28 grams per mole. Yes. So we have PV is equal to nRT. Therefore, PV is equal to capital M upon M into RT. So pressure is 10 to the power of 5 into V, which we need to calculate. Here M is given as 18.5 divided by molecular weight is 28 into, that is in gram it is there. Therefore, here it will be 1000 into 1000 into 8.3 into temperature is 273. Calculate it for V is equal to this. Option D. Yes. Others, what about other students? You are getting option D. It is 14.8. What about other students? Okay. Yes, 17. I'll check it out once again whether we are getting one into root 2 or whether it is root 2 into 1. Okay. So I'll check it out. So last question 1 we will discuss. '17 we will check whether it is A or B, right? So now last question for today's class. If the pressure and the volume of certain quantity of an ideal gas is halved its temperature, already we have discussed this one actually. How the idana already discussed Madidivi. So 17 actually we are getting it as root 2:1. How the root 2:1 anta baratte. So that we will prove it in the next class. It is actually option B. Yes. Okay. If any student is not getting this answer, we will solve this in the next class. So you can be ready for the next chemistry class. See you tomorrow. Okay, students. Thank you.
Thank you, ma'am.
Okay. Tomorrow thermodynamics we will do.
Okay, ma'am.
Okay. Yes, students. Bye. Have a good day.